Alright, let's get into 14.6 here. Yes, solving rational equations. Okay, first off, we're going to start with the definition. A proportion is an equation stating that two ratios are equal. As you can see in the symbols, A over B equals C over D is a proportion. Basically what we're going to have happen here is if you start looking at this, whenever you end up solving this, you'll have things like equal, like 1 equals 1, or 1/2 equals 2 halves, which equals 1/2. Something like that, where we want both sides of this thing to equal out. What we're trying to do is figure out, as you can see here, is there is a value of x here. There's an x variable here, and the LCD is 6x. Okay, what they're saying is whenever you figure out what x is, whenever I plug that in, it's going to make both sides of that equation equal out to be the same thing. So let's work this one out. You kind of see what I'm talking about here. They're telling us our LCD is 6x. So let's multiply both sides by the LCD. On this side, notice that this reduces out to just a 3. Okay. This reduces out to just a 2. So let's rewrite this as 3x minus 5 equals 2 times 6. And 2 times 6, we're just going to write that as 12. So we'll keep solving. We're going to have 3x minus 15 equals 12. Let's add 15 to both sides. Get rid of that plus sign. Don't want to confuse you later in the notes. And we get 3x equals 27, and finally x equals 9. Okay, well let's look at this. Whenever I plug this x back in, I get 9 minus 5 all over 2 times 9 equals 6 times, pardon my dog in the background there, 6 times 9. Okay, well 9 minus 5, that's going to be a 4. 2 times 9 is 18. That's going to equal 6 over 27. Okay, well let's look at this here. These are going to reduce down to 2 over 9. And here we get 2 over 9. So notice they both equal out to 2 over 9, 2 over 9. So let's continue on. That's what a proportion is. Okay, let's look at this. This is going to be a proportion here. On an architect scale drawing of a home, 1/2 inch, okay, represents 10 feet. Okay, what length of measure does 2.5 inches represent? Well, we're going to come in here and represent this by, we don't know how far the bottom part is. But here, we're going to need to change this into an improper fraction, which means I'm going to do what we call the big C method. I'm going to come in here, I'm going to go 2 times 2 plus 1. Well, all of that's going to equal 5, and then keep the denominator. So we're changing that into an improper, so I've got 5 over 2. Okay, here you can do one of two things. You can go ahead and multiply by the LCD, okay, or you can go and just cross multiply. Now I'll show you what I mean by cross multiply. This is literally going to take this guy, and I'm going to cross multiply him up to there. I'm going to cross multiply him up to there. If I rewrote this, this would look like this. It would look like 1/2 multiplied by 10 over 1. And then here, and that's all going to equal 5 over 2 by 10 over 1. And I'm very sorry, that's going to be an x over 1 there. Okay, so notice if I go ahead and rewrite this in that way, I get 1/2 x equals, well, I get 50 over 2. Well, notice I can go ahead and reduce out this 2 on both sides by multiplying both sides by 2. I can get rid of the fraction. Come over here and multiply by the reciprocal on both sides. Okay, doing that on this side, it reduces out that 2. Here, cross reduce, and I'm going to be left with x equals 50 feet. There. That would be your answer on that one. Okay. Now, you know how to do these now. Let's look at an example you're solving containing rational expressions. Same things we've done in the last lessons. We're going to find the LCD of the fractions. List any restrictions, okay? Multiply both sides of the equation by the LCD, simplify, solve the resulting equation, okay? Well, let's look here. What do we got going on here? We've got another proportion going on here, which means I can go ahead and come in here and start trying to find the LCD. Well, my LCD for this one is going to be x minus 4. Well, look right here. Here, I can factor out an x, and I'm going to be left with x minus 5. So my other LCD is going to be x, and then x minus 5. Okay, well, let's multiply everything by the LCD. So I've got x, x minus 4, and x minus 5. Over here, I've got x, x minus 4, and x minus 5. Okay, coming back in here. Well, the x minus 4 cancels. Over here, the x cancels, and the x minus 5 cancels. So we can go and come back in here, and notice I've just got a 1 up here. So, rewriting this, I'm going to end up having x, x minus 5, equals 3, x minus 4. Okay, let's start simplifying. We've got x squared minus 5x equals 3x minus 12. Now let's get everything over to one side because I've got a quadratic here. So we're going ahead and subtract 3x and then add 12 to both sides. Rewriting, I'm going to have x squared minus 8x plus 12x plus 12 equals 0. We'll go ahead and use the AC method, okay, which means I'm going to have to create a 12 over here. What's going to look good for that? Well, how about a 2 and a 6, both of them negative, because when I have negative 2, negative 6, that creates my negative 8. Multiply both negatives together, I get a positive. 2 times 6 is 12. So my final answer is going to be x minus 2 and x minus 6. All of these, x minus 2 equals 0, x minus 6 equals 0. So I get x equals 2 and x equals 6. Looking up here, my restrictions are going to be 4, 0, and 5. So I'm all good. So this right here is going to be my final answer. And that right there is just a few examples. We're going to have a few more examples in the notes down below. And also on the first one, I do show a different way. It kind of makes it a little longer. But also on that first example, how you don't have to cross multiply, but you can also find the LCD and do all the multiplication from there. So anyways, everything's in your notes, and then we'll kind of move on forward from here.